any further ado, I'm going to let Ric actually explain his background, but I would like to thank him straight away for joining us, and very much looking forward to this presentation, Ric. So welcome, Ric Kemp from Race Technique Engineering.
Thanks, Vicky. It's almost a shame I know so many people, because now I can't lie. But anyway, what do they say? A legend in my own lunchbox, all that sort of stuff. I thought tonight we might just have a quick chat about shock absorbers in general. I'll try not to be too detailed and try not to be too boring. And if at any point you want to ask a question, there are no dumb questions. So please, tonight's the night. If you've always wondered whether, you know, gas shocks or oil shocks, or, you know, what does two-way mean, whatever, fire them out, and we'll do our best to give you a nice, easy to understand answer. I've got a slideshow that we used to do as just a standard car club thing, and towards the end I put in a lot of photos of race teams and different cars over the years. Been lucky, some of you may or may not know, but I spent time in Europe in the 80s in world sports cars and got to Le Mans in 87. Time in the States, I've done New Zealand, Asia, Australia, and really lucky to have done so many different categories. I mean, I've worked at the top end, and you might have seen in the list, you know, I started looking back at some of the drivers, and it's Giancarlo Fisichella, Mika Salo, you know, Craig Lowndes, Whincup, Murph, Richo, all the way down to, you know, kids coming up through go-karting into Formula Ford. And it's really good because you bump into them at the racetrack, and, you know, Matt Brabham will always still come up and say good day and remember your name. And so I feel really blessed that I've had, you know, nearly my whole life involved in motorsport. So what I think we need to do, we're just going to, Vicky and I are just going to swap the hosting for a sec so I can just run through this slideshow. Can everybody see on the screen at the moment that RTE, that great big thing with my name? Yep. Okay. Well, look,
Ric, would you mind just having a go to see? I changed my view. I just wanted to test before I swap over the hosting, just to see whether it actually works now. Yes, look at that. It's working.
Okay. Well,
I think it was just the way that we had it set up before. Excellent. So you should be good to go now.
All right. Fantastic. So any questions, please fire in straight away. One of the biggest things that I always bring across with this one, suspension movement creates shock work. The number of times that I've had guys ring me, even to the point where they've tried Bilstein, Coney, Penske, Ollins, and then they ring me and say, mate, I don't know, the car's a pig, you know, what brand do you recommend? And it's a simple thing such as it's so low it's sitting on the bump stops and the shock doesn't get a chance to do its work. Or I had a guy with a D Tomasa Pantera one day, and mid-engine, he was a little bit scared of it, and every time he tried to turn on the track, the thing would just swap ends on him and fire him off the track backwards. And I always have this standard thing where I say, look, just go and set the car up at ride height, and I want you to measure how much travel you've got up into bump, how much travel you've got down into droop from ride height. And he came back with, the front was pretty good, it was roughly in the middle, but at the back it had 90 mil of travel upwards into bump and 3 mil of travel downwards into droop. And essentially every time he tried to turn a corner, we'd pick up the inside rear wheel and swap ends and fire him off backwards. So essentially I got him to shift the pickup point for the shock to put the shock back in the middle of its travel. And 2 weeks later he rang me and he said, oh, I'm really embarrassed now. He said, I don't actually need anything from you, which is fine. But the big thing, shocks need travel, and it's a very easy mistake to make the car look fantastic, but not understand what's happening inside and understanding how much travel you've got up and down. Shocks depend on speed. We'll look at the difference between a gas shock and an oil shock in a minute, but essentially oil shocks or hydraulic shocks, they need a lot of travel. They need a lot of speed to work efficiently. Gas shocks were designed primarily around really short travel. Penske were the first ones to do that in the early 90s or late 80s with Indy cars and what have you. So speed dependent. And essentially all they're doing is converting that mechanical energy into heat. It's a bit like a radiator will convert the engine thermal energy into heat dissipation as well. So it's a pretty simple thing. Yeah, we used to call them heat exchangers. I can remember some off-road stuff, and at one point we put temperature stickers on because we didn't really know what they were getting to in Outback Challenge and things like that. We knew it was starting to peel the paint, but they were seeing 120 degrees. So shocks can certainly get hot. And if you're into four-wheel driving and trips, interesting thing to do is to actually pull up for your morning tea or lunch break. Just go and have a touch of your shocks and see how hot they are, and that'll bring it home to you. A lot of people say, oh, these double acting. All shocks are double acting. They do work in rebound and compression. Rebound is when the shock's coming down, and compression is when the shock is going up into bump. So all shocks have been double acting since decarbon back in the late 50s. I don't think there's been a non-double acting shock since then. And the biggest thing to remember about shocks, I think we've written here, tyres provide grip, shocks provide contact. Realistically, a lot of guys talk to me about, they're at the racetrack, it's Friday practice, they've got a lot of understeer, and they're saying, what do I do with the shock? Shock is always the easy thing because there's a knob you can get to quickly. But honestly, balance in a race car is going to come primarily from your springs and your sway bars. Shocks are all about grip. If your shocks are old and inefficient internally, the oil's degraded. Don't forget, shocks are full of oil. We change engine oil regularly. Everybody forgets about the poor old shock. So keeping your shocks in good nick will give you a lot more grip. Maybe it's only a tenth a corner. Most tracks in Australia have 12 corners. That's over a second a lap. So shocks are more about, the little bits, the 2 out of 10 change, the 3 out of 10 trimming. If you've got a car that's understeering or always oversteering, that tends to be a spring and a sway bar thing. This is just a quick look at, if there were no springs or shock absorbers and a wheel hit a bump on it on the road surface or the track, it would bounce up into the air. As soon as you add a spring to the equation, spring, funnily enough, is, as well as supporting the weight of the vehicle, it's trying to push the tyre down onto the ground all the time. I often talk about the back of a car and whether you should run a sway bar or not, because essentially when the car brakes and turns, what keeps the car level and keeps the tyres in good contact, if you have a sway bar on the back that's quite big, it'll always be picking up the inside rear wheel. If you've got springs and no sway bar, it's always pushing the inside rear wheel down. So quite often having a bigger spring and a very light bar is a better way to go at the rear of the car. So that's what happens if you have springs without shocks. And as soon as you add a shock to the equation, that's why the whole thing comes together nicely, and the whole system works fairly well. Gas shocks, oil shocks, realistically, it's an age-old question. A lot of people, it's my background, I suppose, so maybe it's not that interesting, but all shocks have oil in them. When they talk about gas shocks, the gas is an additional component, but essentially all shocks have oil. And the common designs for shocks are essentially twin tube hydraulic, and that's a fairly standard looking Coney race damper that Dave Mottram will recognise straight away. We've just had some discussions about historic race cars and these. And then you get something like this. Now that's a V8 supercar rear shock, and this is we call it a gas shock, but essentially this is all full of oil about halfway up the canister, and there's a gas piston, and that separates the gas from the oil. But essentially all shocks have oil. This probably shows it a little bit easier. On the right-hand side of your screen, you'll see what an oil shock or a twin tube shock looks like. I haven't got a pointer here, unfortunately, but there's an inner tube full of oil and the outer tube is half full. So as the piston goes down, the outer tube fills up with oil, and then as the piston and shaft extend into rebound, the oil comes back down. So it's constantly raising and lowering its oil level inside. On the left-hand side of the screen is a gas monotube where you can see the yellow part, the hydraulic oil. There's the piston and gas down the bottom. So as the shaft and piston go in, if you have a bucket of water full of water, put your arm into the bucket, the water will displace, it'll spill over. And it can't do that in a sealed gas shock there. So that's why the piston has to be able to move up and down, and it compresses the gas chamber. And on the V8 supercar shock you saw a second ago, that gas chamber is actually sitting in that separate canister. That's a hydraulic damper dyno that a manufacturer would use, like Coney, Penske. They're worth a lot of money, and obviously very strong and very accurate. This is my dyno, which you can see in the background here, with a premiership photo of the Hawthorn football team just in the background. was hoping that would provide a response. And look, at the end of the day, I can remember a time when there were probably only 3 of those type of dynos that I have in the country. You know, they're worth a lot of money. I shipped a row rig out from the States, and what a shock dyno will do is run a shock absorber through a series of strokes and speeds and simulate what actually happens on the car, on the track, or on the road. Pushing a shock in and out by hand, you don't really, you can imagine the speed the shock works when you hit a bump or hit a curb, even jumping on the brake pedal. You'll never simulate that by hand. Quite often, you can pick up 2 shocks, push it in and out by hand and go, oh, gee, they feel a bit different. But you need a machine to run them at the sort of speed they run at in the car to really understand what's happening inside. So that's what a dyno will do. My typical dyno test will incorporate a warm-up period, which is a bit like 2 laps of a racetrack. And then I put it through a standard test that Row Rig developed. And I've input a few bits from Coney over the years where we've worked out all the really important speeds that the shock works at. When we talk about shock speed, you can imagine the speed the shock works at when you jump on the brakes, jump on the gas, tip it into a corner. That's kind of like in the middle speed area. If you're coming onto the front straight at Phillip Island, the shock's hardly working. That's low speed for the shock. And obviously, if you hit a curb, the shock moves really fast. That's high speed. But you need a machine to achieve all of that. These are different types of graphs. The green line with the P, that's progressive. That's typical of a rally car. Last year was interesting. I did some work for Molly Taylor's ARC car, the Subaru, and they'd had an issue since the car had been built, and she'd run a complete season and a bit, and always had this issue with the back of the car. It was always taily and nervous, and so they shipped over the fronts and the rears. I don't do a lot of rally dampers, but the guys that were building the car and, or, you know, maintaining the car, I'd known quite well, and I'd sort of met Molly a couple of times on and off. Lovely person, very talented behind the wheel. And funnily enough, it's a Ryger set of dampers, which is about a $26,000 investment just in 4 shock absorbers. And they have a thing called a ride control valve, which essentially, when the car is on its wheels on the ground, you set this little valve so that the car can have normal damping on the road, on the dirt road, and cope with all the up and down and work it has to do. When it sees a jump and gets air, this little valve pulls on a rod that allows all the damping inside to just dump, and the wheel then drops to full travel, so that when the car lands, you've got the whole stroke of the suspension to soak up the landing. So when you see those rally cars land like a cat, that's one of the reasons. That simple RCV valve, and almost every manufacturer in the world has tried to copy the Ryger RCV valve, and every time they've taken them to court, and every time so far they've won. So it's a very simple thing. But cut a long story short, the kit that Molly was running, the RCV valve in the rear of the car, I can remember I had the front and the rear, and I could see the difference on the dyno, and I'm looking at trying to understand this RCV valve, and then I noticed that the dimensions were just slightly different, and it looked as if they'd actually machined the seat for the RCV valve too much. And I sort of rang him and said, look, I don't know if I'm really this smart or not, but I said, I think I just need to put a washer in here and kind of fix it. And they said, oh, well, give it a shot. We've got some testing happening in a couple of weeks up in the middle of Victoria. So we machined up this washer, put it all back together, and completely transformed the car. And she'd been running it like that since day one. So and she that was the first event she absolutely smashed them that season. So anyway, P, that's a typical rally type of progressive damper. D, the blue line, that's what's called degressive. It's typical of a race car. On the track, you want a lot of damping force down low so that the race car gets propped, and it really responds to turning the knob on the damper to make the car handle a little differently. And the line in the middle, that L line, that's a linear trace, and essentially that's kind of, you don't really know where to start with valving. Quite often shock manufacturers will just make a linear line. The faster the damper moves, the more force it produces. When it's hardly moving, hardly produces any force. And funnily enough, everything goes in cycles, I guess. Everybody had degressive damping at once, and quite often, like the Lotuses, most of the Elise and the Exige in the Nitrons, they run a linear rebound, and it works an absolute treat in that sort of standard Lotus configuration. when people talk about one-way, two-way, four-way, essentially they're talking about how many adjustments. If you look at this shock, an adjuster here for compression or bump, and not sure if you can see that little window in there, but put a pin in there and move that, and that's rebound. So that would be a two-way shock, and essentially they're separate. This one does just rebound, this one does just compression. The V8 supercar rear, and this is the older style rear. They don't use this now, they've got a control shock, but this has one on the canister, two adjusters just here, which is rebound and low speed bump, that's mid speed bump, and then it has a fourth adjuster up here, which is a blow off. So that's a four-way. The Ferrari that we won Bathurst in 2017, the 12-hour, the 488 GT3 spec car, that had 5 adjustments. It's probably one of the few reasons I can have a job occasionally, because I can at least, what's the old saying, baffle them with, no, let's not go down that path. I think they say that if you know 5% more than the other person, they consider you an expert. I rest my case. These are a lot of calculations. There's all sorts of things that I suppose happen in the background. Quite often I get people asking me, for example, what sort of spring rate should I run? You know, I have no idea. I've gone from, you know, the Toyota engine in the back of the Lotus to the Honda engine, or, you know, from the early 4-cylinder engine to the supercharger. There is a standard way to calculate out a spring rate, and it's, well, I need sort of 3 or 4 measurements on a car, and then you can work out whether the springs on the car are in the ballpark. To give you an example, I had a guy in Tasmania with a sports sedan, Bruce Baker, RX-7, and he sent all 4 shocks and springs across. I had him do all the measurements before everything was sent. I'm looking at everything, and I said, so Bruce, you've got an 800-pound front spring, 600-pound rear. Where did those numbers come from? And he said, oh, I looked at as many sports sedans as I could, and most of them were running about that sort of front spring and rear spring. It's just an average. And I said, okay, so your car actually has a rocker rear suspension. It's got 3-to-1 motion ratio. It actually needs a 2,000-pound rear spring. And he just sort of looked at me like I had 2 heads. And I said, look, it's just numbers. I said, you know, I could be wrong, but what say I send down a pair and you put the whole thing together, and if you don't like it, just send them back and we'll credit them. And of course, you know, 2 weeks later you get a phone call, completely transform the car. So standard calculations can be handy sometimes just to see if things are in the ballpark. Another good way is obviously, you know, if there's a really fast car on the track and you can be friends with that person, you can look at what they're running. Pit lane engineering, we call that. I can remember when I first started in V8 supercars, it was with Gibson Motorsport in the days when Gibsons were really, you know, the benchmark, I guess, a bit like DJR, Penske are these days. And there was a point where Alan Heafy was running the team. Probably shouldn't talk about these stories. And he gave each of the mechanics a little, you remember the little throwaway cameras? You'd buy them at the chemist. You'd take, you know, 12 shots, and then they'd process the pics and throw the camera in the bin. And essentially, the mechanics had to give that to their girlfriends, and then as they were unloading cars out of the back of the transporters, the idea was to get the girls to stand in front of the truck as they were unloading, and, you know, the boyfriend would take a photo of the girlfriend, and in the background is the car rolling out the back of the Pantec. And then they'd process the photos, and they'd blow them up and look at what springs they were, where the pickup points were for the trailing arms, where the roll center was, all this sort of stuff. And it was really funny. One by one, people twigged to what was going on, I guess word of mouth too. And eventually all the teams had these vinyl press stud sheets that actually went under the back of the car so that you could roll them out without people actually seeing what was going on. Pit lane engineering. So essentially, there's a lot of good books out there, and I've quite often given people the name of some good books. So if you're at all interested, you're welcome to, you know, get my number off Vicky or whoever, and I'm happy to, you know, give you some easy reading right up to some of the really difficult stuff. And it runs through a lot of those calculations. It runs through things like, I mean, you know, they quite often say that compression controls unsprung weight, and rebound controls the sprung weight. You know, by the book, that kind of is the deal. But, you know, these days, rebound does so many things. I mean, compression or bump is a bit like spring rate. You're driving down towards Honda at Phillip Island, you jump onto the brake pedal, and the front nose of the car dives down under brakes, and that makes the back get all squirrely and nervous. If you want to, limit how much the front dives down, you could increase the spring rate or increase the compression damping. I mean, bump is a really useful tool for working out spring rate. Quite often on the back, for example, a lot of people have complained about understeer. They brake, change, and as they turn and get on the gas, that weight transfers to the rear and the car just squats, takes all the weight off the front. There's your mid-corner understeer. So you could go up in spring rate, but how far do you go? Well, if you've got a bump adjuster, you just simply increase the bump or stiffen up the bump. Oh, that feels better. I've got a little bit less understeer. You can keep going. If you max out the bump, you'd go up in spring, say 50 pound, put the bump back in the middle. It's a good direction finder. So quite often it's a bit more than what the book says. I mean, look, we won't get too technical tonight. I'm happy to spend as much time as you like. And if anybody's got any questions, I'm happy to answer. But, a lot of what I find you have to do, even though, I've been lucky to work with dampers for 30 years, you have to understand springs. Do we look at linear springs, keeper spring system, progressives? I thought I'd bring along, I mean, that's essentially a linear spring. What we mean by that is that this one is 325 pound per square inch. So it takes 325 pound to compress that an inch, and then another 325 pound for the next inch, and another 325 for the next inch. That's a linear spring. The difference is something like this one, which is progressive. I'm not sure if you can see this clearly, but the wire thickness here is a lot bigger than here at the top. So what happens here, the spring changes its rate, and this is an increasing rate spring. Essentially, they have what's called a J curve, and you kind of need to know the load on one corner of your car that's going to act on this spring to see where you are in that curve. But quite often you can get a spring that increases its rate as it dives down under brakes to prop the front of the car, and then drops its rate to help with cornering. So it's like you've got a softer spring. It doesn't roll around as much as a soft spring. Sometimes you might run a linear spring, and you might have heard of keeper springs. Essentially, they go together like that. You've got a light rate spring that'll just keep everything trapped and stop any unsafe untrapping. Maybe you've jacked your suspension up at some point and the spring's wobbled around, and as you drop it back off the stands, you hear this big clang. That's the spring seating itself. Needs a collar to join the two, and essentially that's a neat way of keeping everything trapped, giving yourself a little bit more travel. In droop travel, from ride height, as the suspension goes down into droop, you've got to remember that if the spring becomes untrapped, it won't use any more of that travel. The shock might have another 30 mil of down travel in it, but it'll only use it if the spring is pushing it down. So sometimes keeper springs are really good for that. Roll centers, it's an interesting term. Essentially, a lot of people talk about roll centers, but it's a theoretical thing. If you've listened to Malcolm Osler's tapes on YouTube, he and I have very similar opinions. It's just theory, basically. I've seen more people brought undone by trying to fix their roll center. A typical case was Shane Bradford. He runs a Trans Am sports sedan from Queensland, very fast Trans Am, and we had a test day at Morgan Park, and I can remember looking at his data and thinking, geez, you're a bit of a girl on the brakes. Sorry, Mick, what I meant to say was he's a bit light on. Anyway, cut a long story short, I said, look, I want you to head down the straight. You should be pressing about 800 pound on the brake pedal. This thing, it's a bit like a V8 supercar, front engine, rear wheel drive. V8 supercar drivers at 1,000 pound pedal pressure. So he went down the front straight, leapt onto the brake pedal, and instantly torched both front tyres on the inside to the canvas. Lots of smoke, came back, tongue hanging out, very, upset. Got out of the car, and I said, mate, that was a complete. So he says, oh, I can never brake hard. That always happens. I said, okay, well, let's have a quick look. And what they'd done, the upper control arm, they'd changed the pickup point of the arm to bring the roll center up. And what had happened, it was on such an oblique angle that as the suspension moved up, it pulled on 4 degrees of neg camber as the suspension went into bump. So essentially when he braked, both front tyres did that. On the very inside edge of the tyre, torched it. So luckily they had the old pickup points there. And I said, let's forget about the roll center. Let's put the pickup point back to here. Let's bring the camber change down to something like half a degree. And instantly he found nearly a second a lap, within 2 laps, just because he had confidence under brake. So roll centers, very theoretical. I think the easiest thing to think about in regard to that area is lower control arm. You need to have a look at your car, if it's a track car, even a road car, and I understand the appeal of dropping a car down in ride height. They look great. But as soon as your lower control arm has this sort of angle on it, it's going downwards to the center of the car from the wheel. Essentially, you've dropped the roll center below the ground and the car will fall over in corners. Roll center is the easiest way to think about it, is a broom handle. If you're sweeping the floor with a broom at 45 degrees, the broom works pretty well. Drop the broom handle down parallel to the ground and try and sweep. Won't sweep. There's no grip at the broom head. Essentially, your lower control arm, same thing. If it's on this sort of angle, it's going to give a lot of potential grip to the contact patch of the tyre. So we could cover a lot more ground on roll centers, but it can be a good tuning tool. And if you're building a suspension from scratch, certainly worth thinking about, but it's more about lower control arm angles and camber change. Roll axis, that's how much the car has in rake. Most cars need to have forward rake. They need to keep the weight over the front. Biggest thing for most people on a racetrack is understeer. Sometimes it's brought on by the driver. A lot of times it's brought on by the driver. I've only had probably 2 or 3 drivers that have, had enough front turn. It's always the standard thing. Give me more turn, give me more turn. But essentially, you imagine a front wheel drive trying to pull a boat up a boat ramp, a slippery boat ramp, and it's going to spin the front wheels because all the weight's over the back of the car. If you put that same boat onto a Commodore rear wheel drive and try and pull up the boat ramp, it should pull no dramas because you've got weight over the back wheel. So a bit of roll axis keeps the weight over the front, really helps the car turn. Go too far and obviously the back will want to come around and swap ends on you. Camber and caster, look, not sure how far you want to go with all of this stuff. We won't get too technical, but understanding how much of both of those to run can be a function of tyre temperatures, looking at the tyre wear. In the last few years that I was engineering race cars, I was one of the few engineers that still looked at a tyre. It was a lost art. I can remember Ron Tornak, we were at a V8 supercar meeting at Sandown, and we'd been doing some work for Larry Perkins, and I was up the back, and this old bloke sidled up next to me. We're sort of looking at stuff and seeing how it all works, and he says, nobody ever seems to do pyros anymore, checking the temperature of the tyre. He said, it's just strange. And I go, yeah, why is that? I grew up with all of that. I've still got a $1,000 pyro at home that, prints it all out and sends to the computer and all. And he goes, yeah, I don't know. It's a bit of a lost art. And I didn't know who the bloke was. I went up to Barry Ryan later and said, who's that old guy? And he says, oh, that's Ron Tornak. Who unfortunately passed away recently. Ackerman, it's one area where I differ with Malcolm Osler on his little video. He says, yeah, don't worry about Ackerman, Well, it does make a difference. I won't get too technical, but essentially to draw a line through the upright and converge it in the middle of where the rear wheels are, if your steering link is on that line, you have Ackerman. And Ackerman is essentially the inside wheel turning more than the outside wheel as the car goes around a corner, because the inside wheel does less distance. There was a time back in the sort of early 70s where everybody said, road cars need Ackerman, but this is a race car. We've on slicks. It doesn't make any difference anymore. So everybody took Ackerman out and even went to anti-Ackerman, all sorts of things. And then after a while, everybody started realizing if they ran toe out, both wheels pointing outwards, that they'd get better turn in the middle of the corner. And toe out, of course, is a bit like Ackerman. So everybody ended up going back to Ackerman. A lot of things go in cycles. Anti-dive, pro-dive, gee, it's another contentious issue. I've seen plenty of people put so much anti-squat in the rear, anti-dive in the front, that it puts all the load through the uprights and the arms instead of through the spring and the shock absorber. So essentially you can have so much anti that the typical case was the Gibson cars with Murph. You could go, from one end of the scale to the other with a shock absorber adjuster, couldn't feel it. So we went to Calder, which was the test track designated for Gibsons. And I can remember the day we said, let's put all the arms parallel to the ground and go and drive the car and just see what we've got, see where we are. And the car only dived an additional 10 mil under brakes at the front, so not a lot. And then we did a bump change on the front to stop, you know, how much it dived, and Murph went, I can feel it. You know, he was feeling 5 clicks of damper again. So they can be good, they can help, but a lot of times they can also bring you undone. Okay, moving on. Bump rubbers. I mean, this is a little hard to understand, I guess, but tarmac rally cars. Paul Stokel is one of the Lotuses that I do. And Paul and I have known each other for a long time. There's a poster up the back here with the Lamborghini when he was in Nations Cup. The very first Lotus Elise that he ran in Nations Cup. I can remember doing that car. That's where we first met, and it became a giant killer. He was taking it to all the big bangers in those days and beating him at tracks like Winton and, you know, all the stop-go type places. But with his Lotus for tarmac rallying, you kind of need spring rates for tarmac work because like Targa Tasmania, for example, it'll be dry in the morning, wet in the afternoon. You know, there's moss growing on the roads in some of those forest areas, and you can't sort of dial from a dry setup to a wet setup. You end up, you know, having to have something that'll cope with everything. So the springs are probably softer than what is ideal to give that grip in the wet, but to stop the car from just, you know, diving under brakes, rolling like an old boat. We use a bump rubber as a secondary spring. So for, you know, 50% of the travel, it's just the spring and the damper and the sway bar. But then if it really, you know, it's dry and you get a lot of grip and you're going from high speed, jumping onto the brake pedal very, you know, aggressively, that bump rubber can become a secondary spring and just prop the car under brakes. Very difficult to have them work on the rear of any rear-wheel drive car, but certainly the progressive bump rubbers are very important. Aero cars, the Ferrari that we ran at Bathurst, the Audis, typically, because they produce nearly 1,800 pound, well, nearly 2,000 pound of downforce. Typical F1 car produces 3,000 pound. We've all heard the story of being able to drive upside down in the tunnel. Well, you know, if they could find a tunnel long enough that would give them, you know, a good run up, they definitely could. But those GT3 spec, the current cars, they run about 2,000 pound. A V8 supercar, about 600 to 800 pound of downforce. So this weekend at Bathurst, when they talk about taking a bit of wing out, they don't really play with the sort of numbers that we play with. But what happens with those big aero numbers, at speed, it just pushes the suspension down and the car would scrape itself to death on the track. So again, you use a bump rubber as a secondary spring. And I can remember the very first time I was taught about them in Europe at Le Mans, you used to paint the underneath of the skid on the front and the rear. You'd set the car up with bump rubber and packers, and the driver would go and do a lap, fire it into the pits, paint's still there, so you pull one packer out, do another lap, and you just keep pulling a packer out at a time until you just take the paint off. And then you've got the relationship right between the bump rubber and the packer and, you know, having the whole thing propped nicely. On the front of that Ferrari, we ran at Bathurst in 2017, 6 mil of travel on the shock until we got into the bump rubber. At the rear, we ran 15 mil. So 6 mil front, 15 on the rear. So bump rubbers can be a pretty important tuning tool, especially for light cars like Lotuses. There's all sorts of new technology starting to come in. Through shafts, V8 supercars were running an Ollins TDX damper, which has a through shaft. You know, we can spend some time. And is anybody at all interested in that area? We'll keep moving. Things like FSD, which was a new design that Coney came up with, frequency sensitive damping. Buses are great, big, tall. They have a very high center of gravity, but they need control and also passenger comfort. And all of a sudden they came up with this damper that was stiff when the road was smooth. And if you look at this diagram where that secondary oil flow comes through, it had like a secondary damper inside. It didn't just blow off the damping, but essentially when it saw a lot of frequency, and when I talk frequency, we're talking sort of milliseconds, it would move to the secondary damper inside. So it had soft damping when it saw bumps, and when the bumps went away and it was smooth, it went back to stiff damping to stop the roll and people feeling seasick. There's obviously a lot more stuff now done by computer. HSV had the MRC, magnetic ride control. That's the computer with shock pots determining the travel, going back to a program that someone's written saying, okay, this road's bumpy, we'll soften off the suspension. Porsche, they have, you know, soft and firm button on the dash. I did a car for Mike Pritchard. It's a 991 GT3 RS. Again, he wanted to run Targa and standard road car, and said, "Gee, I've got to tell you, this car feels fantastic." He said the soft setting is probably ideal for the wet. He said, but the firm setting is too firm. You know, can we change the valving and the shocks, but keep all the electronics? He said, I love the ability to press the button. So we revalved all just the firm setting and made it more supple with a bit more top end rebound, you know, a bit of the old magic wand stuff. And he actually came second outright in a standard Porsche 911, well, revalved, but standard spring rates, standard bars and what have you, that year at Targa Tasmania. And he said, you know, it was the perfect setup because he could press the button for the wet days and go back to the firm setting, which had become more supple and more accepting of bumps, and it was just a really nice balance. So there's a lot of different systems out there. I was lucky in my time at Coney. I worked there for 12 years, and I got to go back to the factory for training. And Coney were doing BAR Honda, McLaren early on, and the guy that did all the F1 damper work, the valving, a guy called Sam. The first guy I went to see when I was at the factory in Holland, and we had long conversations. A couple of years ago, I actually went back to the UK to the Dynamic factory and said, look, I used to work for Coney. Now I work from my garage at home. You know, all I understand about new technology is what I read. Can you bring me up to date? I'd been doing a lot of work on dynamics in the AMG Benzes and Ferrari and what have you, and spent 2 days there. And he brought me up to speed with everything that was happening at the time and what they were using in F1. And funnily enough, dampers in F1, they're nothing special. You know, I can remember looking at the valving and just thinking, I could do that. You know, it's an interesting. It's all about aero, obviously, in F1 at this stage. They keep trying to bring the aero back, but essentially, it's still. I mean, at one point in F1, they had 3 different construction sidewall tyres for the different tracks. The shock and suspension hardly moved. There was a great video called 50 Years of Formula One on Board. They started off with an onboard camera with Fangio at an aerodromo circuit in Italy. And I was watching him doing this around the steering wheel. He's just going down the track. And then at the end of this little segment, they showed the camera. The camera was about as big as half a fridge, sitting bolted to the car in front of him. So he had to actually look around the camera. But sensational to see his in-car driving style. Anyway, when it gets to that period of Senna and Alain Prost and all those guys, that was the period where there was virtually no suspension and it was just different construction sidewalls. Bumpy track, soft sidewall tyre, high speed track, a lot of aero, stiff wall. And they do a similar thing in NASCAR in America. So F1, I love F1. It can be boring, but been lucky enough to at least see the sort of suspension stuff they do. This is the, I guess, probably my favourite year ever. I've been lucky. You know, I've won Bathurst twice now. I had a 1-2 with TMR when it was a production car race with Evo 10s, the first year that they were released. 2017, we won Bathurst with the 488. And we had Jamie Whincup, Craig Lowndes, and Tony Verlander, the Ferrari test driver. And an interesting story, it was a big dollar outfit. I can remember Mark Coffey saying to me, who runs Maranello Motorsport, saying, for the 12 hour next year, we've got Lowndes and Whincup. And I hope Jamie's not listening. And I said, yeah. He said, what's wrong? And I said, Craig can drive anything. I've worked with him a couple of, ran him in an Audi in the 12 hour, but Jamie's never driven anything, mate. He's driven a Formula Ford and a V8 supercar. He's never driven a car with aero like this. He doesn't understand how all this stuff works. He'll be our liability. And anyway, we had a 2-day test organised for early January. The 12 hour was going to be mid-Feb. And everybody was there, the whole team, car. First time Jamie was going to drive the car. And I said to Jamie, you might as well jump in and head out of the pits. We'll spend the first half of the day. You can just get used to where the pedals are, the steering wheel. We talked about left foot braking, all sorts of stuff like that. And he did 3 laps and the gearbox actuator broke. And there was no gearbox actuator in the country. And that was our test, done. So we spent the rest of the day practicing driver change. And packed up and went home. So Jamie actually arrived at Bathurst to drive a $500,000 full GT3 spec factory Ferrari race car with no laps under his belt. And Tony Verlander was excellent. He's the Ferrari test driver. That was his baby, that car. He did 4 laps just to make sure everything was good. Said, yeah, dropped down, said, yeah, he's looking after rear tyre. He said, very easy to drive over top. You know, you Aussies have good setup. He said, I'm very happy. And he said, no, you want Jamie in the car? I said, yeah, probably for most of the day, mate. Go and get yourself a coffee and a paper. And he sat in the corner of the workshop, didn't crack it that he wasn't driving, just happy to sit there, do his bit. And Jamie spent the whole day in the car. Started off about 5 seconds off Verlander's pace. By the end of the day, this is how good the guy is. He was down to within probably about half to 3/4 of a second off Tony's pace. Lowndesy jumped in at one point, usual thing, big smile on his face, a couple of jokes on the radio. He was probably, you know, within half a second of the pace fairly quickly. So beautiful car. And yeah, at the end of that race, I can remember they absolutely tore it to pieces. They checked fuel capacity in the tank, ride heights, wing profile, you name it. We were there until about close to midnight whilst they tore everything apart to make sure it was all legal. And then we got to have a Burman. But great year. I spent a season in Asian GT, worked with Tony Oliut. That was a fully fledged McLaren back deal. It was when the 650S was released, 3 cars. And boy, you know, going to places like Fuji, we went to Korea, China, Sepang, all of those places. Just had a sensational time. Lots of stories. We won't go there. That's Lowndesy and Luff and Rod Salmon, who owned the Audi. That was in 2013. And interesting story. Rod, who owns the car, just an absolute motorsport enthusiast, loves it. Only wanted to do a handful of laps and then hop out of the car, but there was a minimum driver time he had to do. And at the start of the weekend, he was 10 seconds off the pace of Lowndes and Luff. And this was with MPC at the time. And I remember they just bought a simulator. So Lee from MPC and I set up the simulator. We had some genuine real data from a race car, and I was driving the simulator, and he kept changing the physics in the game so that we had same top speed, the same braking ability, same mid-corner speed. And then I said, you're going to spend the whole day either in the real car or in the sim. And he was absolutely buggered by the end of the day. Had all these people coming down to the track that he wanted to have lunch with. No, sat in the truck or the car, and we got him down to within 2 seconds of both of those guys' pace. So I'm a bit of a believer in simulators, I must admit. Yeah, he did a great job. Yeah, look, I've been lucky. I've worked on Lambo, McLaren, Audi, Ferrari, Aston Martin. Just had a fantastic time in GT racing. Oliver Gavin, brought him out from the UK to do the 12-hour one year, and we led the race for probably a third of it. And unfortunately, one of the drivers had a little mishap with the wall that tended to put paid to it fairly quickly. When Erebus Racing first started, that was an interesting time. We shipped out 2 brand new AMG GT3 spec full factory race cars, and did all the testing with Tim Slade down at Phillip Island, getting ready. And I'd said that Black Falcon were the gun Mercedes team in Europe, and they were coming to do the 12-hour, and why don't we see if we can stand around in the back of the garage? So Ryan Madison, who was the team manager at the time, rang them, and they said, look, you run the number 2 car. You know, we'll gain from your experience, you'll gain from ours, it'll be great, we'll have a good time. So we popped a couple of Aussie drivers in, Tim Slade being one of them, Peter Hackett. And in the other car, we had Jeroen Bleekemolen on as our lead driver, who was probably the best sports car driver in Europe at the time. But in the other car was Rob Wilson in the number 1 car. Now, not sure if anybody here would know Rob Wilson, but in the UK, he would be probably one of the most respected trainers of drivers in Europe. Quite often you'll see Lewis Hamilton make a call, and it'll be to Rob Wilson to talk about a particular corner or something the car's doing that he's not quite happy with. And he's one of those sorts of guys, got a lot of very important people on his list. Anyway, cut a long story short, we beat the number 1 car with the number 2 car. We came second outright in the race that year. And I can remember clearly, Lowndesy was in the Audi, and I was with this car, and we knew it was going to rain at one point in the day, and it was going to be a short dump of rain, then dry up for probably an hour, and then it was going to rain really heavily again. So we'd already had a bit of a plan. I said to Jerome, we needed him in the car when the rain was coming. He was in it. The rain started coming down, and all these cars have traction control, ABS buttons. I mean, the Ferrari has 2 traction controls, one for where the traction control cuts in, one for how aggressively it cuts in, 10 different positions for ABS. It has a throttle control. So essentially, if the driver's too aggressive on the throttle, you can doughy up the first 50%, or if he's, you know, too easy on the throttle, you can make it more aggressive. So a lot of electronics, but essentially on the radio, I said to your own, righto, here's the rain. If you at all think it's totally unsafe, then pit and we'll put wets on. But what's going to happen is every person's going to dive in, put wets on. If we can get through this and stay on the dries, when the rain stops, we're going to get a big jump because they'll all have to come back and take their wets off. And he said, yeah, no problems. We'll, you know, press on the buttons. We'll be okay. The only 2 cars that stayed out were Lowndes in the Audi and Jerome in the Benz. Stayed out on the slicks, dropped a whole lot of places. Everybody fired it into the pits to put wets on. And basically, I reckon it was about 35 minutes later, the rain stopped. Everybody stayed out for about 10 minutes, hoping the rain would come back. All ended up coming back into the pits. We ended up the only 2 cars on the lead lap. And then another 40 minutes later, when the real rain came, into the pits, put on the wets. And we were the only 2 cars that finished on the lead lap that year. And we came second, the Audi beat us. So great story. Yeah, Lamborghinis, the Hurricane down there, great car. A lot of V8s. I've been lucky to work with Truckee Parsons, Tony D'Alberto. I remember Tony was on the HRT customer support plan, and that meant he had data from HRT, and Matt Crawford come down every race meeting a number of times over the weekend, talk to Tony, look at the data. He lost his engineer, and they asked me to fill in for 3 or 4 rounds, which I was happy to do. Got to go to Bahrain, and you know, had a great time, obviously. And it's funny, at the time, Matt would always say Tony was running last at every round. Nobody really rated him, and Matt would always say, no, don't change anything. Like Tony would come in and ask, oh, can we do something about the front? Yeah, can we fix the rear here? And Matt would say, don't change it, mate. The window's this big. Like, we know what we're doing. It's him. He needs to change his driving. Okay. And I would tell Tony. Anyway, 2 races, and ran at the back of the field. Then we went to Bahrain, no Matt Crawford. And on the plane over, I said, why don't we change stuff, mate? Let's be bad boys at school and see what we can find. And we put some Pro Dive in the front. We changed springs, roll centers, all sorts of things. And Tony was running around in 16th at the end of P2. And I remember his dad coming over saying, so we've obviously got better tyres, haven't we? And I said, everybody's on the same time, mate. No one can bring tyres to Bahrain. We're all on the same allocation. That's a genuine 16. So it's funny, a lot of teams won't change the car to suit the driver. But for me, I'm old school. It's always been, if the driver says he wants more turn, you give him more turn. If he wants the back hooked up, you give him that. And it's funny, feedback from drivers. I do a lot of shock work and suspension work for different levels of driver. And one of the things I often say to them is, look, when you get to the track, keep it simple for yourself. If you're out there, there'll be more in seat time for you in the car, understanding the track, learning the car, just getting more and more laps under your belt than there will in making too many changes, until you can say, drive it back in the pits and say, righto, I kind of need a bit more front here and a bit more rear there, but you know what? If I could only change one end, give me more front turn. Until you can say that, no point changing the car. The number of times that I've said to drivers, what's the car like through this particular turn? And then you'll ask them about another turn. They're actually almost identical turns, but at opposite ends of the track. And it's understeering at this one and oversteering at that one. You know that the driver's just overdriving the car or hasn't any science in his driving. He's essentially just driving off the seat of his pants. So until you can get to that level where they really genuinely know they want one end fixed, you've got to give me more grip at the back, mate. The thing that's on my radar, every time I go over the top at Phillip Island at Lukey there, I know the back's going to bite me. So, you know, what can you do? That's when you make a change. Of all the drivers I've worked with, you probably find that I reckon only 10% can give good feedback. Some very fast drivers. Here's some of the tarmac cars, the Viper. I used to say to Jason, whatever you do, look after my suspension, will you? We built Penske's for that car. So he sent me every photo of the car with it in the air. Just to bring it out. There's a photo of Stokel in his Lamborghini. That was a giant killer. That one's a little bit of air as well. Ray Hislop in his Ford pre-production. Damien Milano, Formula Ford, Matt Brabham, Jack LeBrock, Gary Jacobson, Thomas Randall. You know, it's been great doing the Rising Star program, just watching those guys come up through the traps and helping them with, you know, how to give feedback, how to understand shocks and springs and bars and what have you. It's been really good. Mitch Evans from New Zealand nearly made it to F1. Was under Mark Webber's tutelage there for a while. Lived in the gardener's cottage at the end of Webber's driveway when he was in F1 at working at Red Bull. Darren Hossack when he used to race the Audi sports sedan. Those things are weapons. V8 supercar at the end of the straight at Phillip Island does about 280, 275, 280 kilometres an hour, and that thing's doing over 300. Yeah, very, very fast cars. More sports sedans, Trans Ams. I was lucky to run Todd Kelly as a young lion for HRT. That was when I first came back from overseas. And Todd had come straight out of Formula Ford into essentially a Formula 3000 car with a Buick V6 in the back. Came second outright that year to a guy called Scott Dixon. And he often says to me, geez, I was disappointed that year second. I said, look at Scott Dixon, mate. How many Indianapolis 500s has he won? You know, he's just one of the most accredited drivers in America. Timmy Macro in Formula 3 and, you know, lots of Formula 3 cars. Things like Radicals. Liam Talbot, he won a driving course at Paul Stokel's school for a birthday present. And Paul, at the end of the day, dropped him into the school car, the Radical, and he loved it and said, oh, I wish I could go racing. He said, well, we could race this car. It's only a school car. So he brought me on board to engineer it, a couple of mechanics. And I can remember Paul had no tools, no spares. We didn't even have a fuel drum. We were going up and down pit lane, borrowing stuff for the whole year, and we won the championship. Liam put it on pole at most of the rounds. It was just great. That's the year we came 1-2 at Bathurst in the Evos. Yeah, had a great time with Evos and Subarus. This was interesting. The Holden Motorsport, when they decided to release the VE station wagon, decided to do it at Bathurst for the 12-hour in the production race. So nobody had actually seen one in the flesh until the first time we drove out of the pit garage. And we were still finishing the build on the car on the Friday morning. So, and I can remember that year we came third outright in this great big old lumbering V8. McConville did most of the test work. It was a great year. A lot of TCM and historics. Yeah, a few different guys. Paul Stubber, ex-Speedway, most talented driver. I can't ever recall seeing somebody go. I think it was at the chase at Conrod at Bathurst when they ran there that year, and he was faster than the V8 supercars. It was before they moved up to the 3.1 diff ratio, and he was doing just under 300 k's, and he was actually a little sideways as he went through the chase in his Camaro, and then had to pull it up with drum brakes on the rear. Fairly character building. Paul Stoker, mini challenge, Grant Denyer. Yeah, Grant, funnily enough, Grant is a very, very good steerer. I know he's a TV personality, but, you know, Paul had a lot of speed, would always put it on pole, would win a race, or he'd, you know, get involved in something and maybe, you know, end up with a fifth or something like that. But Grant would always be second, third, second, just kept amassing points. And I can remember partway through the first season, he was actually leading the championship from all these seconds and thirds. And that was the year that he had that incident when he was doing a stunt in one of those monster trucks and broke his back and couldn't finish the season. But very talented young guy. A lot of historic cars. I'm lucky enough to work with Guido with his Formula 1 Ferrari. I think it's around, it's the Michele Alboreto car around the mid-80s. And he'd never driven a race car in his life, was looking for a Ferrari to buy as an investment. And somebody suggested he should buy one of the race cars. And he said, oh, you can't buy Ferrari race cars. And they went, yeah, you can. So he bought two. He got the Michele Alboreto car and I can't remember the driver of the other one now. So there's a spare in the truck if he ever does anything like breaks a gearbox, they just pull the spare out. But lovely guy, and I've worked on some terrific cars. Nicky Lauder's BRM, a lot of Brabhams. That was the 6-wheel Tyrrell. Coney did the shocks on that car. Yeah, had a fantastic time. Drag cars, interesting, very fast, but yeah, 6 seconds, all done. Oh, the Cat racing truck. I got a phone call from Inky Tulloch, and he asked if I could come up and help him with. They were going to build a brand new truck, and I remember arriving in Winton, and he said, "So you've obviously done a lot of truck stuff." And I said, "Yeah, I've seen them." And he said, "What? You don't really?" I said, "No, look, Coney sell a lot of truck dampers. I really haven't had much to do with them." He said, "Well, come on, jump in. I'll take you for a few laps." So I got to do 6 laps in that race truck around Winton. Luckily, their speed limited to 100 k's an hour. But I can remember we approached the sweeper close on 100 k's an hour, and he just flicked this thing into a big speedway slide, and it felt like you were sitting on the 3rd floor of a block of flats. And unbelievable, like over 1,000 horsepower. Just the weirdest thing I've ever done in my whole life. But great exercise. We had a fantastic time with that truck. The bottom picture, you probably can't see it, but there's some steam coming out of the right front wheel because they have water that pumps to the brakes to keep them cool. And that the rule book said we could only run 1 shock per corner. So we used a V8 supercar shock. And I remember the first test day, Inky said, "Feels like the back tyres are going away." I remember touching them, they were cold. They were made of, it's like battery case material. That was the Bandag, rebooted tyres, whatever. And I said, "It might be our shocks, mate." And I touched the shock, and it was like, frying bacon and eggs. So essentially, we were wondering how to make the shocks run cooler because you could only run 1 per corner. And when I came back to work, Marco, when I was talking, he said, "So tell me about the water brakes. Big tank in the back, full of water. As soon as they take off, they flick a switch, they pump water." He says, "Why don't we pump the water to the shocks, run it around the shock body, and then down to the brakes?" And the shocks ran at 35 degrees, fixed the issue straight away. But very interesting times. Lots of Porsches. There's a few shots there of me over at Le Mans. I initially went across to drive cars and ran out of money, so I said, "I'll hang on." I stayed as a mechanic, worked my way up into engineering cars over there. The bottom right is a Lotus. I had a lap record at, I had 3 lap records, but one of them was at Phillip Island in that Lotus. And I can remember Rex Broadbent was racing at the time, and I would beat Rex on the short tracks like Winton. He would beat me at the long tracks like Phillip Island. And the guy that owned it was a guy called Gary Ryan. Not sure if any of you remember Gary. Some of you will, you older blokes. But Gary even went to the trouble of buying a BDG from the UK to put in to try and get more horsepower, to try and get more top speed. And it made no difference at all because the thing is just a big parachute down the front straight. So I was chatting to Rex. We got on well. I said, "Mate, is there any chance you could just let me tuck underneath the back of your car down the front straight? We just want to see how fast this thing will go. It's geared for it." He said, "Yeah, no worries." So the race started, and about 5 laps in, Rex sort of slowed up a little as we came onto the front. I tucked underneath, and it was one of those times where you've probably seen it in the movies. Your foot almost comes completely off the throttle. You're so much in the toe. 2 cars can go faster than one. And I had this massive slipstream. Can't even remember what the speed was we saw. But at the end of the straight, fired it out of the slipstream, went down through turn 1, finished the lap, and broke the lap record.